In this I-Do problem, we have to identify the element that's represented by the PES absorption spectra. And PES stands for photoelectron spectroscopy. And the key to reading these spectra is to look at your axes down here. And I want you to notice that in this one, it's split into two pieces. The top one reads from 10 to 100, and this is binding energy in megajoules per mole. In other words, the electrons that are represented by the peak right here, those are the electrons that are most difficult to remove. Thinking about what that means, they're most likely held closest to the nucleus. And so the sublevel closest to the nucleus, that would be our 1s sublevel. Going down to the bottom line of the spectra, we see it reads from 0 to 10, which means these electrons are a little bit easier to remove, which means we're going to be in the second energy level in the S sublevel. Those two electrons take a little bit more energy to remove than the four that are right here and that read 1.31 megajoules per mole. So those are most likely R2P. They're really nice to give you the numbers of electrons in those sublevels as 2, 2, and 4. So we really can just count up the number of electrons and see that we have 8 electrons. And looking at the periodic table, we can see that that element is oxygen. But writing the electron configuration, it would look like this. We have got 2 electrons in the 1s sublevel. Those are the ones that have the highest binding energy. And then in the second energy level, we have 2 electrons in the 2s sublevel, and it looks like we have 4 electrons in the 2p sublevel. That is the electron configuration for oxygen. That's it.